let's continue what we're doing here. By the way, something I want to add here a little bit before I get started. A question might get asked. What's the point of watching these videos when I can just go through the material that you are currently going through myself on my own time, at my own pace? Um, there's really nothing wrong with that. If you see these videos, you see the sources I'm using, and you want to go through it yourself, you can. But here's a thought. Why not uh, have the video in the background like I do here? I have myself in the front, and in the background I have VS Code and a source I'm using to read from. And while you're reading the material or listening to what I'm reading off the material, you may agree or disagree or add something or want to mention something that pops in your head while listening to or reading the material yourself and throw a comment in there, like the video or whatnot, sort of thing, while you're reading the material. Um, and this is not a new concept. This has been done several times. Not this way, but it has been done several times. If you think about it, whether you're in school, college, regular school, um, work, uh, anything like that. This has just a different name to it. When you're in school, it's more of a study group. Study group will come together and study material, discuss the material with each other in person, sort of thing. At work, it's normally called brainstorming, coming together to try to come up with some new ideas. So, um, why not have the video playing or pause it in the background, read through the material yourself, follow along with the material that I'm reading as I'm reading it, and then maybe even pause the video and put a comment in there. Yeah, I like this section right here, or I agree with what you're saying, or I disagree with what you're saying, or something you could add that you might think would be important or whatnot. And at the same time, you have your text editor up at the same time. Um, all that sort of stuff. Basically, make it a more of a. I don't think there's a term for it yet, but it could be considered more of a study group, I guess, if you're learning C++ at the same time that I am. So yeah, you could have the video going in the background, have VS Code like I do right here. Video go in the background, VS Code up, or whatever your text editor is, and the material you're learning from, read along with me. And let's say you're using Visual Studios or Code Blocks or something else besides VS Code, and you may be like, well, how would I do that on this? Or I agree with that, or my experience in this was so forth and so on. So yeah, we can. I mean, I have no problem with that whatsoever. If you want to throw comments in there and stuff, I go back and look at them and stuff, read the comments, and I may even mention some of the comments in future videos. So if you are learning C++, you don't understand why I'm making these videos. I'm making these videos to share my journey of what I'm discovering and learning about C++. But if you want to create it, make it to where it's more of a study group sort of thing, that's fine too. I can get on board with that, and we can try to learn together, come up with creative ideas together, help each other learn, so forth and so on. But so that's just an idea. If you like it, great. If you don't, that's fine. Doesn't matter to me. Um, I'm going to continue where I left off from the last video. I wanted to throw that out there because I just kind of came up with that idea just a minute ago. So continuing on, common site related questions. How do I sign up for the site? How do I get a login? So if you want to log into this or whatnot and leave comments, I guess, there's a part here for that. All parts of this site are accessible anonymously, therefore no user account or sign up is needed. Is there a PDF version of the site available for offline viewing? Unfortunately, there is not, according to what I'm reading here. The site is able to stay free for everyone because we're ad sponsored. That model simply doesn't work in PDF format. Um, you are welcome to convert pages from the website into PDF or any other format for your own private use as long as you do not distribute them. Um, I don't know if I'm following along with that or not. I don't think I am because, in my opinion, I'm kind of doing, I would say, morely sponsoring the website. And not even really sponsoring it since I'm not paying them, but morely advertising the website, I guess. Um, so I don't know if there's an issue with that or not. If there is, I'm sure they'll let me know. What should I do if I get stuck on a concept? If you don't understand a concept or something you feel stuck on, um, it gives you kind of some things right here. Read through the comments, which the comments are down below. Um, Other readers may have encountered similar challenges. You could also do what I was just suggesting and stuff. You reading along with me and everything like that, or you reading it separately and you throw a comment in on the site itself, or you throw a comment in on the uh, YouTube I'm posting or whatnot, and maybe we can sort it out and figure it out together, sort of thing. Scan through the next lesson or two in the series. Your question may be answered there. So yes, when you get stuck, and I mentioned this in the last video, if you get stuck, move through the material, come back to it later, or maybe it may end up getting answered later on in the study material. Use a search engine to see if your questions have been answered elsewhere. For error messages, ask an AI to explain something to you. Keep in mind that the information provided by AI may not fully be particularly correct or incorrect, I'm going to say. Ask your question on a site that is designed for programming Q&A like Stack Overflow. I've actually never heard of that site, so I may check that out sometime. If all else fails, skip the material you don't understand and come back to it later. You may find that something that was hard to understand is easier with the additional knowledge and content provided by other articles. So yes, and I mentioned that before. What I would do if I forget what something means, use our site index to look up any topics, and I've done that many times before. You want to know more about there, and you'll find links to the lessons where the topic is discussed. The site index is also accessible from every lesson via link in the title bar. So up here at the top, navigation, yeah, you can click that right there, or you can click the site index right there, and maybe find a specific site or a specific spot in the material and stuff to help you understand it. Help you understand it, help you remember something you've forgotten. Do you have any similar sites other than for other programming languages? No, they do not. Maintaining this site requires a lot of time. Doing other languages would require being able to clone myself a few times. So the person that created this site and stuff, they do a really good job, in my opinion. And I hope they keep up this content. And I hope I'm doing my part and stuff to kind of advertise it, help out in any way I can. I do appreciate this site, and I am myself very grateful for it. Next question: can you do a dark mode for this site? Not easily, but you can see. You can not easily, but you can see darkread.org. I've never actually tried that. In my opinion, stuff. I think it's pretty easy to read this site without the dark mode on. I think you might be able to switch it in the settings, but I'm not sure. I've never tried. Finally, one small snag. The site is free because it's ad supported. If you find yourself enjoying the lessons, please consider disabling your ad blocker. The reason that is and stuff is because the ads is what pays them to continue maintaining the site. Um, since it's pretty much ad related as far as that's concerned. The only issue I had with that is, like I said, the ads will kind of make the page jump up and down depending on the size of the ad. It makes it very hard to read it. Um, so, a suggestion, if the person that is making this site, and this is just a suggestion, you don't have to take it at all. Um, but have a spot where maybe donations can be made to help support the site. Because, like I said, the ads, if it's a small ad, it'll shrink the page and therefore the content will move up. If it's a big ad, then your content moves down and then you kind of lose track of what you're reading at the time. I had that big problem right there and stuff. I would have left the ads up myself, but like I said, when it keeps jumping the page back and forth, changing the ads and stuff, that's what makes it very difficult to read the material. So maybe if you could throw a spot in there where people, if they liked it and they're able to support the ad by making donations or whatnot, that might be helpful for continuing to support this site. So next part of this, introduction to programming and programming language. Modern computers are, actually no, yeah, we'll go ahead and start on this part. Modern computers are incredibly fast and getting faster all the time. However, computers also have some significant constraints. They only natively understand a limited set of instructions and must be told exactly what to do. Yes, I think I used this example before. If you was to tell somebody to go from one room to another room, and all the rooms, the doors were closed, uh, they would probably go to that room and stuff by simply opening up the door. Well, the computer is not going to be that intelligent. The computer is going to try to go to that room, but once it gets to the door, it's not going to try to open the door. It's just going to try to walk through the door or whatnot because it didn't get the instructions to open the door first before entering the room, sort of thing. And you got to be very specific about what you want the program to do. A computer program is a sequence of instructions that directs a computer to perform specific actions in specific order. Computer programs are typically written in programming language, which is a language designed to facilitate the writing of instructions for computers. There are many different programming languages available, each of which caters to a different set of needs. The action and art of writing a program is called programming. We'll talk more about this specifically uh, later on in more chapters, upcoming chapters. Um, when a computer is performing the actions described by the instructions in a computer program, we say it is running or executing the program. A computer will not not begin execution of a program until told to do so. So this is one of those specific times and stuff where you got a person standing around and they're not doing anything at all, and you're wondering why they're standing around. Well, think of them more as like a program. They have no idea what to do, and that's why they're standing around. So then you might start off by asking them, is there anything I can help you with? Do you need help with something? Just to find out. Don't just, yeah, just to find out if they're just stuck on something. Some people can just end up being daydreaming and stuff and then lost focus of what they're doing, but yeah. That typically requires the user to launch or run or execute the program, although programs may also be launched by other programs. So you may have one program that launches another program. This is also quite getting to be quite common. It's what we call launchers. You start up a launcher, which is one program, and that program actually starts up another program once you hit the launch button. This allows for you to do things prior to starting into the program. You can add things to the launcher, which then when you hit the launch button and stuff, those programs start up at the same time you launch the program itself. But yeah, that's getting to be a quite common thing, having a launcher for a different set of programs, depending on the program you want started. Programs are executed on the computer's hardware, which consists of physical components that make up a computer. Notable hardware found on a typical computer device includes a CPU, central processing unit, often called the brain of the computer, which actually executes the instructions, memory, where the computer programs are loaded prior to execution, interactive devices, monitor, touchscreen, keyboard, mouse, etc., which allows a person to interact with a computer. Interactive devices, a monitor, touchscreen, keyboard, or mouse, etc. I just read that part, didn't I? I do that sometimes. Um, Storage devices, hardware or hard drive, SSD, flash memory, which retains information including installed programs even when the computer is turned off. So yes, storage devices and memory both can contain information and stuff even when the computer is turned off. This helps with quicker startup in the memory. When it's in storage, it helps with not having to tell the computer to go to the server to get the information. Instead, it's right there on the hard drive, so it doesn't have to travel as fast or take as long to get the information when it's in the storage device. This is why a lot of games would run faster and better and stuff when they were stored on the hard drive. But now games are getting to be a lot bigger. Many programs are too, and therefore not everybody's hard drive or SSD or flash memory will hold all the information. So all the information is kept on a server hard drive, which has a much larger capacity to it. The downside about it is the time it takes for your computer to send the action out for instructions and then to receive those instructions to execute those instructions. Um, Again, if I am not correct about some of this stuff that I'm mentioning and stuff, I am trying to read, but I am also trying to give examples. Feel free to leave that in the comment. If you like the video, click the like button as well. In contrast, the software broadly refers to the programs on a system that are designed to be executed on hardware. And modern computing programs, often interactive with more than just hardware, they also interact with other software on the system, particularly the operating system. Yes, so most programs require the operating system to actually start up. The reason this is because the operating system has components in it that actually get the program started up. Um, you got the compilers, you got the runtime, you got other programs and stuff that will save files, load files. So your operating system has a storage place for, say, hey, this file right here actually needs to go into storage, or this file right here actually needs to go into the RAM, and the operating system and stuff is separating those, telling them where to go, sort of thing. That can also be part of assembly language, which we haven't gotten to that part yet. But so first thing we're going to discuss is the machine language. Um, Actually, I think I've skipped some parts. Let me look through this real quick. Yeah, I think I skipped some parts because I went from, okay. We're not getting into machine language yet. Let me finish the top here first. In modern computers, programs often interact with more than just hardware. They also interact with other software on the software system, particularly. Yeah, I've already read that. The term platform refers to compatible set of hardware and software, OS, browser, etc., that provides an environment for software to run. For example, the term PC is used. Uh, cannot pronounce that word. Um, this is the word right here that I can't pronounce. Uh, Colloquially, something like that. I can't pronounce that word. To mean the platform consists of Windows operating system running on an x86 family CPU. Okay, so first off, PC. Computer science describes this word as a personal computer. Those two letters, personal computer, which is what we now call a PC, but that's where that term came from, or those two letters came from. OS, operating system. So let me type this in here real quick. So PC, I think it's an acronym. I think that's what those are called, but personal computer, if you didn't know that already. OS, uh, operating system. Um, and then the x86 family CPU. I think that's the size of the CPU, how much information it can hold at one time, how many sets of instructions it can hold at one time. The speed is what allows it to get in and out as fast as possible. Well, I don't know 100%. Yeah, I shouldn't say even 100%. I don't know a lot about the CPU, the RAM, and how they function based on speed and size. Um, but if you are writing code, I can tell you right now, the speed is not going to matter that much. I mean, it will help with the program running faster. But what you morely will need since you're writing your own program is the storage space in the RAM space, not so much the speed. If you're writing a program and stuff, the program may be big, so you're going to need somewhere to store it, whether it's a flash drive, hard drive, or SSD. Since you're not pulling this information from somewhere else, you're actually building it yourself and storing it in your own hard drive. It may not be too bad of a thing to get portable hard drives, portable SSDs, or flash drives to be able to store some of these programs that you may end up building. Because like I said, it's not so much about speed, it's about storage. And if you don't have that much storage on your PC, these might be helpful because you don't necessarily need to add more storage to it. You can get external storage devices that are portable. Those also make it very helpful and stuff when you need to transport a program you built from your PC to somewhere else. When you're playing games, and yes, speed is more priority, but when you're building programs, storage is more priority. If you want a combination of both, you're going to need probably a bigger computer that will manage both of them really quick. Anyways, moving on. Platforms often provide useful services for the program running on them. For example, a desktop application might require the operating system to give them a chunk of free memory. So there's that whole, it's not so much about the speed thing as what it is about having the space for it. But a chunk of memory, 1 GB, my PC has 64 in it, so that's plenty of space. Most games don't even require that much, but they might. But when you're writing your own program, the storage space is a big thing, especially when you're trying to run the program, because your program is running solely off of your computer, not anything else. So, um, anyways, so a chunk of memory, create a file over there, or play a sound. Uh, Video and sound requires a lot of space. Those are big, depending on how big the file ends up becoming. The running program doesn't have to know how this is actually facilitated. If a program uses compatibilities or services provided by the platform, it becomes dependent on the platform. And what that simply means is, so if you watch a YouTube video and stuff, the YouTube videos and stuff are not stored on your computer, they're stored on a server, which the time for your computer to get to that server and back with all the information from that YouTube video is what will determine how quickly and how good the video quality will be. This is sometimes also known as bottlenecking, which we'll get into that here in a minute. But anyways, so it becomes dependent on that platform and cannot be run on other platforms without modifications. So I'm not going to try to explain that one. I kind of understand it, but since I don't fully understand it, I'm not going to try to explain that one. Especially since I'm really not teaching this, I'm only exploring this myself. I'm just trying to see if there's any new information in here that I'm going to discover. A program that can be easily transferred from one platform to another is said to be portable. The act of modifying a program so that it runs on different platforms is called porting. Now that we've talked about programs, let's discuss programming languages. This isn't just a history lesson. We'll also be introducing terminology that will come up in future lessons. Machine language. A computer CPU is incapable of understanding C++. or probably any language at that. Instead, CPUs are only capable of processing instructions written in machine language or machine code. The set of all possible machine languages instructions are given uh, that a given CPU can understand is called instruction set. Here's an example, a sample machine language instruction. So you got those two right there. Those two right there can simply end up being a couple different numbers or a couple different letters, a couple different symbols. I have not memorized machine language at all. It is possible to memorize it, but that is a vast amount of uh, different. Yeah, that's huge. Each symbol, each string, each character, each letter normally comes up looking like a bunch of ones and zeros. And yeah, your PC ends up collecting all those and stuff. Pretty much, yeah. I'm not going to try to explain that either. That goes into a huge different category. Each instruction is understood by the CPU as a command to do a very specific job, such as compare these two numbers or copy this number into that memory location. Back when computers were first invented, programmers had to write programs directly in a machine language, which was very difficult and time consuming. Yes, if you've ever studied the history of computers and stuff, uh, you would flip the machine on, it would run real quick. No, well, maybe not even real quick, but it would run the program that it was designed to run. But that program may only print up one number, one letter, one symbol. And then if you wanted to change it to where it would do something else, you had to simply pull wires, put wires in different places. Pretty much you were rewiring your computer to do something else, perform a set of different instructions. And then you would flip it on just to get another thing going. And yes, it was very time consuming. You might get a full sentence and stuff by the end of the day. Computers back then and stuff weren't so much designed to do what they do now. They were more designed to decipher uh, messages, hidden code messages. Anyways, moving on. How these instructions are organized and interpreted is beyond the scope of this tutorial series, but it's worth noting a few things. First, each instruction is composed of a sequence of ones and zeros. Each individual 0 and 1 is called a binary digit, or bit for short. The number of bits in a machine language instruction varies. For example, some CPUs process instructions that are always 32-bit long. Others, whereas some CPUs, such as those from the x86 family, which you may be using, have instructions that can be written very lengthy. It can be a variable length. So I believe I know it's not going to get into this, and I'm not going to dive deep into this either. But something like this, I believe, is uh, that I believe is 8 bits, or also known as 1 byte. Yeah, crap. Sorry. This right here is another one. So when we talk about 64, x64 or x86, I believe that is referring to the fact that it actually can contain 86 bits, but I'm not sure. Somebody that understands hardware and computer components would probably be able to answer that a lot better since they deal with that on a daily basis. Um, Second, each family of compatible CPUs, example x86 and ARM64, has its own machine language. So yes, it deciphers code differently. This is why the compiler is got to be specific to your machine for C++. And its machine language is not compatible with other machine language of other CPUs. This means machine language programs written for one CPU family cannot be run on CPUs from different families. So If you run a game or something like that and your game is struggling to run, it crashes all the time or hesitates all the time, it may be the fact that your machine is not able to understand all the languages coming to it very well. There is, however, programs and stuff that are supposed to be built in for those games to help your machine to understand the code. But yes, this is a very complicated area to understand. I don't fully understand it myself since I'm quite new to all this. So if you want to throw any comments in there on any of that and stuff, you're welcome to. Related content, a CPU family is formally called an instruction set architecture, ISA. So yes, remember that because they use this person uses architecture quite often in his tutorial, and architecture is basically the machine components that you have in your PC, the systems that you have in your PC compared to what you're currently using or what is being used. For example, I know I've gotten a 64-bit memory with a massive CPU. It's not the biggest one out there, but it's quite large, larger than the average. But I am only using VS Code on a 32-bit system. So therefore, the bottleneck or the slow part would be actual VS Code because my computer will actually do more than what VS Code will handle. Anyways, moving on. So assembly language. We're not going to get into this one right now. We're going to get into this one in another video. We'll stop right here with this one. As you could tell, this is very much more detailed. This is why I like this website so much more, because we were already mentioning just the beginning parts. You want to understand C++, and what the compiler does, what runtime is, and all that sort of stuff. In my opinion, if you want to understand it, you got to understand every aspect of it, which includes understanding what the computer is seeing, these bits. So we'll stop the video right there. And like I said, if you like the video, hit the like button. If you want to collaborate on learning this stuff together, that's fine. Throw something in the comments. If you have any comments, questions, etc., throw them in the comments as well. And I will see you in the next video.